Hello friends, this video on isolation of elements part 4 is brought to you by examfear.com. No more fear from exam. Now we'll discuss another method for concentration of sulfide ore. This is used to concentrate sulfide ores, and this method is called froth flotation process. In fact, we studied about this method in the previous chapter, surface chemistry chapter. This method is used to remove Gangue particles from sulfide ores. Please note, this is used only for sulfide ore. The process is pretty simple. This is my raw ore, raw sulfide ore, I'll say. This is my input, and we powder it. We powder it and then we mix it with water. This is my water. Now the sulfide ores, if you mix in water, it becomes wet, right? But we don't want it to become so much wet, so we'll add something called collectors. So what collectors will do is it will enhance the non-wettability of the sulfide particles. And the collectors examples are my pine oil or fatty acid. So these are my collectors. So I will use this collector so that the particles, the sulfide particles, should not get that much wet, because we are now putting this in the water. Okay. Also here, this is froth, right? So we should try to maximize this froth, and we can maximize this froth by using froth stabilizers. So we have something called froth stabilizers. So this froth stabilizers will try to make sure that you get more and more froth. Correct? And froth stabilizers examples can be cresols, aniline. These are my example of froth stabilizers. Correct? So what we do here is we take the raw sulfide ores and then we powder it. First thing is we powder it. We powder it and then we add water, right? And we also add collectors so that my sulfide ore particles, it doesn't get that much wet. Example of collectors are pine oil and fatty acid. We also add froth stabilizers so that we get more and more froth, right? And now what happens is the sulfide particles actually cling or stick to this froth. So if you see this blue ones, small very light blue ones are the sulfide particles. They stick to the froth. Since they stick to the froth, and you collect the froth in another container. So this area has my sulfide particles. And then you can dry it to get the sulfide ores back. So what you get is a concentrated sulfide ore. And that's why this process is called concentration of sulfide ore. Right? That is froth flotation process. Right? So see, the only logic is the sulfide particles get stick to the froth, and we collect the froth somewhere else to get highly concentrated sulfide ore. But to achieve this, what we are doing is we are adding collectors so that sulfide ore doesn't get wet, and we are adding froth stabilizers to get more and more froth. And the impurities, if you see, settle down, because the impurities are generally heavier and they settle down and it is collected. So to get more and more froth, what we do is we pass air from this pipe. Now if you pass more and more air from this pipe and this whole thing rotates, if this thing rotates, you get more and more froth. Typically you can try this in your home. You put some, you take a bucket of water and put detergent. You will not get froth. But if you just try to shake that water, then you will see more and more froth coming up. So same thing we are doing here. This whole thing rotates and creates motion, and this air, this combination of air and this motion creates more froth. Correct? So as I told, this rotating paddle, this is my paddle actually. So this is a rotating paddle. This agitates the whole mixture and this draws air from this pipe and creates more froth. And froth is light. We know that froth is light. This is light. Lighter, very light. Since this is light, it can be easily skimmed off. Right? And we are collecting it here. And then it can be dried and the concentrated sulfide ores are recovered from that. Now the question is, if you have, that is a tricky question. So in this scenario, what we discussed was, we had, let's suppose, PBS, and we had stone, we had iron, we have, let's suppose, clay. So these were my gangway particles, right? So we use froth flotation process and this gets stick to froth and these settle down as impurities. Correct? This is a normal scenario. But what if we have a two sulfide ore mixture? For example, I have ZnS and PBS both. So I have an ore which I got from the earth, and this ore has PBS, ZnS, and plus other impurities also. Right? Other impurities, for example, clay, and let's suppose that we 2 or 3. Now you want to separate them. So if you use a normal froth flotation process, what will happen is both these particles will stick to froth, right? And these particles will settle down. But you want to separate these two also. So these can be done by adjusting the proportion of oil and water. If you see, we are using oil. So to separate these kind of ores, the first method can be, we can adjust the oil proportion. So with that, only one of these will get stick. Or the better way is using depressants. I'll tell you about depressants. This is a better way actually. If you use depressants, then we can easily separate them. What depressant does is, depressant will allow only one of these particles to stick to froth. Why? Because it will react with other particle. For example, in this case, if I use depressant as NaCN, in this case, I have zinc sulfide and lead sulfide, these two ores, and I use NaCN as a depressant. What NaCN will do, NaCN will prevent zinc sulfide to mix with froth, but it will allow PBS, that is lead sulfide, to mix with froth. So with this, if you see, in the froth will have only lead sulfide, because they'll react actually, and they won't. It will form a complex, and it will not stick to froth. Correct. So if you have scenarios like this where you have two different sulfides and you want to separate them, you can use depressant. That's the best way, because this depressant will react with one of these, form a complex, and that will not stick to the froth, but the other sulfide will stick to the froth. So you have to select a proper depressant based on your ore type. Okay, now I'll tell you a very encouraging story. It's a washerman story. See, the whole idea of the froth flotation process came from a washerman. So there was a washerman, and she had innovative mind. She was very innovative. So, and her clients were, these are all her clients, client 1, and these are also her client. Or clients or customer, you can say, right? So she had various clients, and one miner and one chemist. This guy is a chemist. This is a miner. So she had a miner client, she had a chemist client, or she had a miner customer, or she had a chemist customer. So while washing miner's clothes, because see, if miner is her client, she has to wash her clothes, right? So while washing the miner clothes, she noticed one day that the sand and other dirt particles fell to the bottom of the wash tub. For example, this is the wash tub which she was using. See, and she found that all this sand and other particles, they settle down in the wash tub, which she has got from clothes. Let's suppose there was a cloth here, right? So this is a cloth, and from this cloth, these particles settle down. That is okay. But what was surprising was that the copper bearing compound that again came from the cloth of the miner, they were caught up in the froth. This is the froth here, right? Because we are using soap. So all these copper bearing particles, I'll say. So these copper bearing particles were caught up in froth, or you'll say soap suds, right? So this froth, in this froth, all the copper bearing particles were caught up. And she was a little surprised why some particles are stuck up in the froth and other particles are at the bottom. So she explained the whole scenario about this miner cloth to her chemist client. And the chemist client was Mr. Cary Everson. So Cary Everson, he used this idea actually to separate copper compound from the rock earth material on a large scale, because this was for the copper compound. He used this idea to separate copper, and with this we came up with the process of froth flotation process. So with this whole froth flotation process came into picture, right? And since it was used to extract copper from even a low quality ore, copper mining became profitable, copper price came down, right? And the copper production scaled up in the world. So with that, it leads to a lot of development, because copper is used in the development. We know that, right? Copper, steel, these are used. So the copper production shot up, price went down because of this process. And this leads to the development. So you see, everything started from washerman. We give credit to Mr. Cary Everson, but again, the washerman also gets the credit. So with this, the idea behind the main reason why I'm telling this story is anyone can think. So it is innovative mind which brings change. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.